Okay, so can't do as many sets this week as we lead up to Easter with all the church services. So we're still on box 26. We're on radio 7 of 8. This is effectively the last one in this batch. We're going to do 8 of 8, but the 8th set is a gift to me from the customer, so it doesn't go back to the customer. So this means the customer can collect all these radios. So it's LCL Communicator NI440DX, which I like very much. Nobody else does, but I like very much. Except nobody... They're so unusual and difficult, not difficult, different to tune, that I suspect that most of them out there don't work properly, and so people don't think they work very well. Hey! Oh, we've even got the factory mic. Well, that's a smart looking one, isn't it? We may as well use the factory mic. So it uses the square type connector, which was available from the American aftermarket CB accessories people, Workman, and I once contacted Workman to see if I could import some of their products, like the power leads for these, and they said minimal order $10,000. So we didn't bother. I wouldn't have minded 1,000, but not 10,000. Right, I'll plug the mic in. I may have to open this up if the polarity isn't obvious. Yep, the polarity is labelled, so we're okay. So it's crocodile clip lead time. I'll switch the test gear on. That also helps. I've got exactly 10 minutes. Whether I've got another 10 minutes today or not, I'll find out, won't I? Right, we'll pop the PA into there and the test equipment speaker into there. And we'll power it up. And it's come on channel 19. Now move to channel 20. So we'll start with PA. Testing 1 2, testing 1 2 1 2 1 2. That's not good. 1 2 1 2 1 2 1 2 1 2. Very low volume. One two one two 1 2 1 2. We've got low power on in a strange position. No. Got no transmit. It's not even going into transmit. I'll tell you what, we'll use the standard replacement mic off my bench. We've still got no transmit. Back into PA. Testing 1 2, testing 1 2. So PA is absolutely fine on the microphone. So there's a fault with the microphone supply. We'll deal with that later. Not that we fix mics, but you know, we may have to. So it's not going into not going into transmit. Now it suddenly is. So I've exercised it. I would think that's a sticky relay, and I think now it's exercised, that won't be a problem. Okay, good. But we still have a dodgy mic. So let's look at the transmit power. Is picture in picture on? No, it is now. So we're on the 3 watt scale, we're on channel 20, it bangs across, it's doing 3.1. Most of these sets don't do 4 watts. They've got such punchy audio that it really doesn't matter anyway. And as I said so many times, put that in the 3.1 and 3.3. As I've said lots of times before, you don't think that you're getting, if you run 3 watts and you get 5 miles, if you run 3 watts and you get 3 miles, you don't run 4 watts and get 4 miles. It doesn't work like that. No more than listening to an amplifier playing records. If you had a 3 watt amplifier and then changed to a 4 watt amplifier, you really wouldn't notice the difference. It's so marginal. Right, let's look at low power. Well, it certainly is, isn't it? Because it is 50 milliwatts. Back to normal power, and then we'll look at the current consumption. It's 1.2 amps. Let's look at deviation. Wallow. 3.5. And the frequency, which we'll take with a pinch of salt. I'm on, I've done it again, I'm on channel 40. Wallow. That's the same. 2779037 definitely needs to come up. That, I think that's out of spec. Right. So we'll put the signal generator on the same frequency as the radio's working on, so for a fair receiver test. I've got a problem with the deviation meter on this test set. I think it wants some capacitors changing in it, and it's reading right at the moment. It's not inaccurate. It's either working or it's not working. It's working at the moment. So we'll just get through these tests, whip the lid off, and do the deviation on the set. I won't have to set up a secondary deviation meter. There is no time to fix the test set. So if this packed up, we stop doing this work. That's as simple as that. And we'd have probably a year break while we finish other things like organs, and then we'd start again. So, take it lower than that. I don't want to move it lower than that because I'd have to do a different adjustment. So, that's going to be near enough. It doesn't sound brilliant, but the sensitivity doesn't look bad. Well, 1.3 microvolts. Sounds like the usual detector things out, and which is these sets are unusual the way it's done, as I say. If we can get, we can get 20 on this very easily. 2.3, very good actually. So squelch up to full, see where it opens, put this on the attenuator. 100 microvolts, exactly where it should be. Let's see where the sensitivity is at the other end of the scale, set the squelch on the radio to threshold. They usually do have a good squelch on these. It's 3 microvolts, which isn't good at the moment, but that'll be to do with the way the thing is. So if I press transmit, it says 4.5 watts, which it certainly isn't. And if we look at 100 microvolts on the test set, it's 90. It's very close. Meter lamp's working. That's working. No. I'm going to get this lid off. I'll go for my break as soon as I've done the deviation. This test set also has a built-in sign-on meter. We always use an accessory one. I have 3 of these test sets. I can't get to 2 of them because, as you know, there's ongoing building work here, which will be going on for a bit longer, bit by bit. So the other 2, the sign-on meters don't work on them either. So I'm either totally wrong in the way I'm trying to operate them, or something. So very quickly I must remind myself which is deviation. So if the synthesizer's down there, I'm just going to have a quick look on my computer. Okay, and it's the one here on its side. They're all on the side, which is rather frustrating. Wallow. Wallow. That's it. Spot on. So I've got an average here of 2.2, which is what I'm looking for, and 2.5 absolute peak. We won't be doing the VCO on these. They don't play up. I've shown you how that's done, and it's so complex we will not do it every time. I don't think I'm skimping on things like this. There is an extra fee. So it's like taking your car in for service, and then while they're there, you know, you say, actually, whilst you're doing it, I want you to take the speedometer out, and yeah, right. Well, they're not going to, are they? There'll be an extra fee. So we'll do the frequency. Test set's now been on long enough. Well, I was thinking it wasn't going to go up then, but it is. Right, we'll come back to this after lunch, if we can. Right, I'm back with you for a few more minutes. I really want this out of the way. So, long enough lead to hopefully not unplug, unsolder the speaker. So if we look at my notes, and I've done this before, of course, we've got this chart. So we're working around those. I've gone and disconnected it. So let's look at the power meter. So really, anything over where we are now, and it's absolutely fine. It's already doing 3.1, 3.2 watts. Let's see whether we can get a bit more out of it. We were struggling with one of the coils on a Cybernet yesterday, and we used quite an expensive plastic trimming tool, and I was struggling because it was a bit tight, and somebody did suggest an Allen key. That's all well and good, but not with it in transmit. So you might find it's a bit tight. You can get the core out, but you must use either a ceramic or a plastic trimming tool to make the adjustment. So we're at 3.5 watts. So on channel 40 we are at 3.4 watts, and on channel 1 we're at 3.45 watts. It's actually a bit better balanced. What are we drawing on transmit? I'll just put it back on channel 20. It's absolutely fair. It's 1.31. So on low power, the adjustment is that's RF meter. It's there, and it's annoyingly a switch at the back. Why would anyone turn it down to that? There we go, 400 milliwatts. Back to normal power, and we'll just make sure the meter is set to read what is being done. So we want that to read bang on the 4, which it now does. So deviation, wallow, that's still reading absolutely fine, so that's good. Tick that off. Well, we'll go on to the receiver now, and this is where things get different. So I'll switch the oscilloscope on. We've got S9 already on the signal generator. Hopefully we've got rid of the noise on one of the microphone channels. I took the plugs out. You know, when I had the previous mixer desk, which didn't do digital formats, so although it was very higher resolution than this, with the broadcast one, how do you get it to go when it's in a broadcast analog format? How do you make it go into a digital format? I've no idea. And so you have to buy something different. And we've gone from the £10,000 disc mixer desk with XLR connectors to a like £700 one aimed at this type of thing, but you've lost the quality. 3.5mm jack plugs are basically crap, aren't they? It doesn't even recognise SM58 microphones, you know. So you have to use a preamp. I find that unbelievable that a mixer desk doesn't know about SM58 microphones. But there you are. So the detector is which? We have IF injection level, and the detector's there. Right, we'll switch to the oscilloscope. And that was already spot on, even though it sounded out. Right, we'll go to the synod meter and hope we can bring it up considerably from where it is at the moment, because it's capable of really good results. And this one isn't doing it at the moment. We'll drop the squelch off. I can't go that low. So we're on a different scale to normal. See if we can bring it up a bit. Tiny little bit. No change. Ah, that's where we are, one of the IFs. Let's put a bigger signal on. I'll tell you something else we'll do. We'll make sure that the signal generator is somewhere like, oh, it's not far out. We'll just make sure the signal generator's on frequency. Yeah, that wasn't near enough to make any difference. But I will go back to that. That was out as well. We've got IF injection level. That's the improvement. And then there's one they put the cover on, which I don't want you to touch. Well, that was spot on, I'll give them that. There we go. I'm just going to go back to front end. It's not particularly hot. So now we have what? No, I'm not satisfied that 0.9 is as low as it will go. Transmit. Right, so I'll say we've seen hotter, but that's now at 0.9 of a microvolt. So what can we hear it down to? To answer that question, 0.3 of a microvolt is what I can hear it down to. Right, let's put an S9 signal on and adjust the S meter. We'll bang on S9. Oh, the sockets work. So that leaves us with squelch, which was already spot on but may not be now. Right, so we'll go to full squelch and put this onto the attenuator controls. No, it's not now. It's not coming in at 100 microvolts, it's coming in at 300. So we will need to now adjust the squelch. That's the one there. They're all horizontal, sorry, they're all vertical, which I don't like. There we go. That's now coming in. So now look at the sensitivity side. Set squelch threshold on the radio. Signal generator back on. It's trying to come in at 1 microvolt. It's coming in at 1.3. So that's improved that sensitivity with that realignment. You know what? I think some of the volume control. I'll take the power off. The volume control needs the switch cleaner on it. And so does the squelch control. Just wiggle that around a bit and put the set back on. Good. Well, it didn't take much doing, but I've seen better. But that doesn't mean it doesn't work great, so we'll see how it works on an on-the-air test. It's alright having laboratory instruments telling me that things work great. Quite a lot of these new sets read great on laboratory instruments, but then you put them on in a car in the field and they don't work great. There we go. So while we've got it on the instruments, Let's have a look at the mic. I'll put that back up there. Wallow. No. I'll tell you what, we'll do this on PA. 1 2 1 2 1 2 1 2. Very, very quiet. So we'll start by spraying the switch. Testing 1 2 1 2 1 2. Wallow. Testing 1 2 1 2 1 2. So have we got a duff insert? Just before we write that off, I'll short that to there. Testing 1 2 1 2 1 2. Wallow. Yeah, it does lots of rattling. It's as if it's just as if the microphone is assembled backwards into this housing. So you've got this plastic housing. It's just as if the bit you're talking to is on the back and the bit you don't talk to is on the front. That's how it's sounding. Anyway, when we open it up, it's pushed in, isn't it? It's all pushed in. What a shame. You know what? In my organ workshop, I've got a vacuum cleaner. So with this is knackered, but you know what? I'm going to see whether I can pop the diaphragm back out using a powerful vacuum cleaner. I've nothing to lose. Okay, so no, that didn't work out. So what we're going to do is put one of these Chinese inserts in instead. So these are a bit wider, but we can just get this in, and because we've got this rubber here, it can push down on that. It's about, what, a millimetre wider? 2 millimetres deeper, shall we say. So we'll take these wires off. Start by tinning this. hopefully wiring it into position. It's already got a sliver of paper in because somebody's not been satisfied with how it presses. Let's take that out. But it's not like the moulding's broken. Testing 1, 2. There we go. So this is a situation where one of these relatively cheap inserts from China has worked. Testing 1, 2, 1, 2, 3, 4, 5. Well, that sounds like normal. So we'll go to CB and turn the volume down rapidly and just see whether our deviation meter's playing ball. Wallow, 1, 2. A little bit more gain than I would like there. I'm not going to readjust the. It's now 2.6 peak. 1, 2, 1, 2, 1, 2. Wallow. I've set it for the standard replacement mic. So throw all that away. Just to show you on the walkie-talkie. Testing 1, 2, testing 1, 2, 3. I don't know what I'm not testing on this. The rod's a bleed. Yeah, that works. Right, we'll swap the test instruments for the roof aerial. So, as usual, as I say most times, it's an Antron 99 type of aerial. I think it's a Solarcon 99. One Nano Roger. Roger. As usual, they sound off frequency. That's because they are off frequency. Right, we'll get our bench dog out, and if we can today, we'll do a scratchy corner test with Mr. Chippy. Leave that parts with the squelch shop. So I'm glad we were able to sort the mic out, because at least he's got that original mic now. But of course it's not going to sound as it did. So when we do the on-the-air test, we'll use the standard replacement mic, and then we'll go over to that at the end. Thanks for watching the LCL Communicator NI440DX later version. The early one is the one with the yellow meter.